Okay, so this one is another example. Hopefully you're able to do the seatwork. You can just compare your work to this. Now prove that the limit of 1 minus 4x as x equals 1/2 is equal to -1 using the precise definition of the limit. Again, limit laws, very easy. You can just plug in and you do get the value of -1. But how do you prove it using the precise definition? It's 2 steps once again. So in our solution, so we have step 1. This is our scratch work to guess delta, okay? So you want to guess delta given epsilon is given any epsilon greater than 0. So given epsilon greater than 0, our task is to find a delta greater than 0 such that, okay, so start with our premise in the statement at least. So this is what we wanna actually get at later on in step 2. So if 0 is less than the absolute value of x minus 1/2, because that is where x approaches, is less than a delta, then the absolute value of the function minus 4x minus the limit value of -1 is less than epsilon. So in the scratch work, we start with the conclusion. So note that 1 minus, 1 minus, so the absolute value of 1 minus 4x minus -1 less than epsilon. So we can rewrite that easily as, so it becomes 1 plus 1 becomes 2 minus 4x absolute value and then less than epsilon. Okay? And then we can actually, because our goal is to be able, really, if you notice the pattern, our goal is to be able to come up with x minus 1/2. So it will have an expression for delta. So therefore, we can now rewrite this. So we can factor out 4 to be able to do that, or factor out a negative. First, maybe let's factor out a -4. Inside, we have -4, and then what we'll have is x minus 1/2 instead, okay? Then less than epsilon. Okay. Now, since we actually want to have a positive number at a time, because it's inside absolute value, I can take out -4, and it becomes a +4 only. So 4 absolute value of x minus 1/2, then less than epsilon. And so now I can divide everything by 4. So epsilon over 4. Hence, we now have what we want. Notice that we have the absolute value of x minus 1/2 as well. And so we can let the delta to be epsilon divided by 4. So hence, we can let delta to be less than, to be equal to rather epsilon over 4 or smaller. Okay. So now we now have step 2, which is formula. So in our formula proof, we just state the definition as given, but we now also specify a value for delta. So given any epsilon greater than 0, let delta equal to epsilon over 4. So if 0 is less than the absolute value of x minus 1/2, less than delta, then, okay, so the function is, 1 minus 4x, and the limit value is -1. So if we simplify this, say 1 is to be less than epsilon, but if you simplify, how can we show that? We simplify this, then it becomes absolute value of 2 minus 4x, which we have shown is just equal to, bring out the 4, and it's just going to be x minus 1/2. But we know this to be less than 4 times delta, but that's just equal to, so since delta is just epsilon divided by 4, it's just equal to epsilon, okay? Just to make sure, because I have no space. Okay, you just make sure you understood where it came from. You also just erase this to make it clearer. So that's less than, again, that's actually less than 4 times delta. But that's equal to 4 times epsilon over 4. So that's just equal to epsilon. Okay. So what have we actually shown? We have shown that thus if 0 is less than the absolute value of x minus 1/2, less than the delta, then your function, which is 1 minus 4x minus -1, is just absolute value of that is just less than epsilon. Okay. Therefore, the limit of 1 minus 4x as x approaches 1/2 is equal to -1.